Welcome to this explainer. You know, most of us rely on network routers literally every single day, right? But we rarely stop to think about how they actually work. I mean, how does a picture on your phone leave your house and cross the entire globe in just mere milliseconds? It's kind of wild when you think about it. Well, to understand these invisible traffic controllers running our digital lives, we need to dive straight into what I like to call the exit door analogy.
Okay, let's dive into this with a slightly strange, but I guarantee highly relatable scenario. Why on earth does your wireless printer still work perfectly when your internet is completely down? Seriously, think about it. The Wi-Fi icon on your laptop has that dreaded little exclamation point, right? You can't load a single web page, no streaming, absolutely no emails. But if you hit print on a document, boom, it shoots right over to the printer sitting across the room without a hitch. It seems like magic or maybe a weird glitch, but it's actually a really vital clue. It points to a fundamental boundary in networking, and honestly, solving this little mystery is the key to understanding everything about how our devices actually talk to each other.
So to solve that mystery, we first need to draw a sharp distinction between two devices that get conflated all the time: the switch and the router. A switch operates entirely inside your local area network or your LAN. Its only job, literally its sole purpose, is to connect devices within the exact same physical room or building, like you and that printer. It does this using physical hardware identifiers called MAC addresses to just bounce data back and forth locally. But the router is fundamentally different. The router is the border control office bridging entirely different networks. It relies on logical IP addresses to route data outside your LAN. So think of it this way. If the switch is a hallway connecting the bedrooms inside your house, the router is the heavily guarded front door leading out into the bustling city street.
And that right there brings us to the primary job of the router. It safely bridges your local network out to the massive, chaotic public internet. It is the sole gateway between the little micro-environment of your home or office and the macro-environment of the web. Without it, well, your local devices can whisper to each other via that switch all day long, but they remain completely isolated from the outside world. To actually get out, the router performs this brilliant trick called Network Address Translation, or NAT. It takes your private, localized data packets, strips off your internal IP, stamps them with its own single public IP credential, and securely escorts them out into the vast expanse of the global internet.
So the crucial point is understanding exactly how your devices actually find this border control office in the first place, and they do it using something called the default gateway. The default gateway is simply the local IP address of your router on your network. Think of it as the absolutely critical exit gate for all unrecognized external data. Whenever you connect to a network, every single device, your phone, your laptop, your smart TV, gets handed this exact gateway IP address. It is the absolute linchpin of internet connectivity. Because without knowing exactly where the specific exit gate is, your device is effectively locked inside the house, just blindly wandering the local hallways with zero way to reach the outside world. You know, the sheer blind faith your computer places in this gateway is actually pretty fascinating. Let's say you type a website into your browser. Your computer looks at that destination IP address and instantly realizes, whoa, I have no idea where this is. It's definitely not the printer, it's not the server down the hall, so it essentially throws its hands up and declares, destination unknown, sending to default gateway. It doesn't need to know the complex multi-hop path to some server in another country. It just tosses the data packet over to the router, basically saying, hey, this isn't local, you deal with it. It's such a brilliant, highly efficient delegation of duty.
But here's where the tech trap snaps shot, and this finally answers our opening question. If your computer is somehow configured with the wrong default gateway, it's completely trapped. It will send all that external web traffic straight to a dead end. But because the local switch relies on those internal MAC addresses we mentioned earlier, it can still talk to the office printer without a single hitch. You can print all day long, but you have zero internet access. So that blinking Wi-Fi error light, it usually doesn't mean the entire global internet is broken. It just means your poor device is constantly knocking on a non-existent exit door, totally unable to get out.
Let's move to and see how this builds. Once the router actually receives that data at the correct exit door, it has to know exactly where to send it next, right? It figures this out using a routing table. A routing table is basically an internal directory, like a dynamic map, used to calculate the absolute optimal path to an external destination. Now, for a standard home router, this map is relatively simple. It basically just says, send all non-local traffic out to the internet service provider. But as your data travels further out into the web, it hits these massive, city-sized enterprise routers. And these backbone routers use highly complex routing tables to map out the entire globe, charting optimal paths across hundreds of different interconnected networks.
And when we talk about this complexity, we are talking about processing at a completely unimaginable scale, millions of connections happening simultaneously. In large-scale telecom networks, enterprise routers aren't just handling a few family smartphones. Oh no, they act as massive traffic controllers, calculating the absolute fastest paths for millions of concurrent video calls, high-frequency financial transactions, and streaming movies, all at the exact same time. It's wild. They are digesting the entire map of the internet in real time, holding massive routing tables in memory, and making these split-second decisions on where your specific tiny data packet should hop to next, just to minimize any lag. But here's the catch. The physical infrastructure of the internet is constantly under threat. Underground cables get severed by construction crews, data center servers randomly go offline, regional power grids fail. Because of all this chaos, routing tables can never, ever be static. They have to dynamically and automatically shift paths to ensure speed and completely bypass broken links. This whole process is largely handled by something called the Border Gateway Protocol, or BGP for short. Think of BGP like the internet's global GPS navigation system. If a major fiber optic cable between New York and London suddenly goes dark, BGP ensures the routers don't just drop your video call. Literally within milliseconds, the routing tables update, the global maps redraw themselves, and your data is instantly rerouted through a different, safer path. It's like a living, breathing, self-healing network. All right, now let's bring this incredible global map all the way back down to your living room or your home office. Because let's be honest, when the internet drops in the middle of a super important meeting, you really don't care about a broken fiber link in Tokyo, do you? No, you want to know exactly what's broken in your house. And that brings us to a field technician's best-kept diagnostic secret, the ping test. This is the exact actionable framework field engineers use to figure out exactly where a connection is failing. So instead of just blindly unplugging things, resetting routers, and crossing your fingers, you can actually use the network's fundamental logic to expertly isolate the problem. And this brilliantly illustrates how simple executing this really is. Step 1. Open your computer's command prompts or terminal and run the ipconfig or ifconfig command to find your default gateway IP. Boom! This reveals the exact digital address of your router's exit door. Step 2. Execute a ping command to that specific address. A ping is essentially a tiny digital sonar echo using the ICMP protocol. Basically, your computer yells hello to the router and then just waits to see if the router yells hello back. It is a direct, undeniable test of that local pathway. Okay, let's break down this ultimate cheat sheet matrix so you can diagnose the puzzle like a total pro. If you run the ping and you get replies received, awesome. Your local link layer is perfectly good. Your computer can successfully talk to the router. So the problem isn't inside your house. You need to investigate your internet service provider, maybe an external cable outage, or an issue with the modem itself. However, if the ping times out, well, your computer can't even reach the exit door. You have a local layer issue. You need to immediately inspect your physical environment. This could mean a broken Ethernet port, a conflicting IP address on your machine, a dropped Wi-Fi signal, or maybe the router itself has just frozen and requires a hard reboot. To summarize this perfectly, a successful ping equals an ISP issue. The exit door is wide open, but the road outside is blocked. A failed ping equals a local hardware disconnect. Your exit door is completely deadbolted from the inside. By simply testing the connection to that default gateway, you instantly cut the entire troubleshooting process right in half. You transition from endlessly guessing what's wrong to knowing exactly which side of the wall the problem actually lives on. It's a real game changer. It's just amazing how much clarity comes from understanding one fundamental piece of the puzzle, isn't it? The router isn't just a flashing box sitting on a dusty shelf. It's the ultimate bridge, the border control, the exit door. So I want to leave you with this provocative question. The next time your connection mysteriously drops, will you know how to find and test your own exit door? Honestly, I highly recommend you try running an ipconfig and a ping test today while your internet is working perfectly, just so you can see exactly what a healthy gateway looks like. Thanks so much for joining me on this explainer, and keep exploring.